Hi everyone, this is Miss Rapp, and this is our last video of semester one or quarter one, whatever you're calling it. We are done after this video. Congratulations, you guys have worked so hard on online learning. We are all so proud of you. Today we are doing lesson 6, solving quadratics by the quadratic formula, pages 184 to 187. Please take a moment, get those out. Okay, take a moment and solve these square root problems. So quickly, 16, square root of 16 is 4, because 4 times 4 is 16. 125, you make a factor tree. And you're, okay, well, I know that's 5 times 25. And you circle any number that's prime, and you keep going. Okay, well, our final answer, it's a square root, so we're looking for pairs or twins or friends. Like, I have a lot of analogies for them, but I always say you're looking for pairs. So I have one pair of 5s, so that means a 5 comes out. So these 5s are gone, but then this other 5 is stuck. So that's the answer, 5 root 5. Okay, this next one has a negative in the front. So whatever our answer is, we're just gonna make it negative. So step 1, make a factor tree. And there's no wrong way to start these. Like, you could start at different multiplication problems. Factor trees are great because you'll always end up with the prime factorization. So I know that 7 times 21 is 147, and I know that 7 is prime. And I know that 21 is 7 times 3. Well, I'm looking for pairs. I see one pair of 7s, so that gets to come out. So I get 7 root 3. But don't forget, it's actually negative because times -1. Okay, here's something new. A negative on the inside. I can rewrite this as the square root of 32 times the square root of -1. The square root of -1 equals I. I is a new thing we're learning. You didn't learn about it in Algebra 1. You did not learn about it in geometry. You learn about it in Algebra 2. So it just means that whenever you have a negative on the inside, you're going to plop an I on the outside, and I'll show you what I mean. So I know 32 is 8 times 4. I know that's 2 times 2. We got some primes. 4 times 2. Got lots of primes. Okay, so I see 2 sets of 2. So I know I'm going to take 2 2's out, and there'll be a 2 stuck. There's also an I because of that -1. So our final answer is 4I root 2. Lovely. Okay, so here are my tips for simplifying radicals. Step 1, make a factor tree. Step 2, circle prime numbers. Step 3, look for pairs. 4, whatever doesn't have a pair stays inside the root. Okay, so my tips for negative radicals, it's one step different. So step 1, pull out -1 and write I. And then follow steps 2 to 4. So it's the same thing, just with that I. So whenever you see a negative square root of 1, that just equals I. Okay, we're going to use this to help us solve the quadratic formula. Let's go for it. Okay, so step 1. Notice that these are the same thing, just one has a negative on the inside, so that means I'm going to have an I somewhere. So I'll make a factor tree for 128. That's 32 times 4. That's 2 times 2. Well, that's 4 times 8. We're going to have a lot of 2's. Okay, so it's kind of hard to see, but I have 1, 2, 3 perfect sets of 2. So I'm going to pull out 3 2's. So that's 2 times 2 times 2, and there's a 2 stuck. So this answer is 8 root 2. But then over here, this is just, I could split it up like this. So then I know it's 8 root 2 times I, which is 8I root 2. Okay. Not too bad. The next one, I'll make a factor tree for 320. Okay, well, I know that's 16 times 20. That's going to be 8 times 2, 4 times 2, 2 times 2. See how you just keep going? Well, this will be 5 and 4. Remember, I'm circling all the prime numbers. I have 1, 2, 3. I have 3 sets of 2, so that's 2 times 2 times 2. And there's a 5 stuck, so that's going to be 8 root 5 for the first answer. And then all of the second one is saying is negative 8 root 5. I did all that work already, just multiply it by a negative. Notice the difference of the placement. Notice the difference of the placement. When the negative's on the inside, you get an I. When the negative's on the outside, you just multiply by a negative. So here, we have the negative on the outside. So I'm going to find the square root of 128. Oh, we did that already. Look at number 5. So the square root of 128, so I know this is going to be negative 3 times 8 root 2, which ends up being negative 24 root 2. We want to work smart, guys. We want to work smart. We did that work already. We don't got to do it again. Okay, negative 252. Notice the negatives on the inside, so I'm going to get an I. So I'll rewrite that as 4 times the square root of negative 1 times 252. You don't have to rewrite it. It just helps me. So a factor tree for 252. I start dividing 252 by numbers. I get 36 times 7. Well, that's prime. And that's 6 times 6. That's 3 times 2. That's 3 times 2 again. So I have a set of 2's and a set of 3's. So I get 4 times 3 times 2 root 7 times I. The 4 just comes over there. The 3's and the 2's come from there. So my final answer, well, that's going to be 6. That's going to be 24I root 7. Take a moment. Look over these. We're going to learn about the quadratic formula today. This is going to be very helpful. When you are ready, go to the next page. Okay, this is all relevant because we're learning about the quadratic formula. Let's go for it. Quadratic formula, you learned about it in Algebra 1. You go over it in geometry. We're going to go over it again in Algebra 2. So this is really a refresher. This really is a refresher. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, this entire thing, over 2a. Here are some tips. Check your letters. Make sure you plug it all in right. Solve root first. Step 3, simplify. Okay, so while we're here, I just want to talk about some tricks that they do. This comes up a lot on the SAT. They talk about the discriminant. So the discriminant is b squared minus 4ac. So the discriminant is what's inside the root. So using the discriminant, you can find out like different things about your quadratic. So for example, if you just do b squared minus 4ac and your value is greater than 0, you'll have two real answers. If it's less than 0, you'll have two imaginary. If it equals 0, there's one real solution or one real answer. Okay, let's put this into practice and see how we do. So moving on. Let me fix this. Great. So step 1, I label A, B, C. I plug in x equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 4 times negative 18 all over 2 times 4. So step 1, check your letters. Negative b, good. B squared, 4, negative 18. Okay, good. And now let's slowly start simplifying. So that's going to be positive 6 plus or minus. That'll end up being 36 plus 288. All over 8. So that's going to be x equals 6 plus or minus. That's going to be 324, and the square root of 324 is actually 18. So we get two answers. X equals 6 plus 18 over 8. X equals 6 minus 18 over 8. So this is going to be 24 over 8, which is 3. And that's going to be negative 12 over 8, which is negative 1.5. Okay, not bad. Number 10. Number 10 is not set equal to 0. So we have to do a step first. 8x squared plus 10x plus 11 equals 0. Must be set equal to 0. Now we can start. X equals negative 10 plus or minus the square root of 10 squared minus 4 times 8 times 11 all over 2 times 8. Take a moment, check your letters, make sure everything goes where it's supposed to. Let's start simplifying. That's going to be 100 minus 352 all over 16. X equals negative 10 plus or minus negative 252 all over 16. Well, negative 252 looks familiar. We did that one already. We found out that negative 252 was 6 root 7, so I'm just going to use that again. X equals negative 10 plus or minus 6i root 7 over 16. That I is there because of that negative. Okay, you're almost done. You can go one step further. You can go one step further because these are all even. So I'm going to divide everything by 2, and I'm going to get negative 5 plus or minus 3i root 7 all over 8. And that's how you can leave your answer. That's an 8. All over 8. Okay, let's try the next one. Everyone is so afraid of word problems. I am here to make us not afraid of word problems. That is my personal life goal. As a math teacher, let's take a moment and read this. A rocket is launched from atop a 101-foot cliff with an initial velocity of 116 feet per second. The rocket's path can be modeled by a formula, h of t equals negative 16 t squared plus velocity times time plus the initial height, where v is the velocity and h is the initial height. Find how long it will take for the rocket to hit the ground after it is launched. Round to the nearest tenth. Hitting the ground means equals 0. So step 1, let's write an equation. H of t equals negative 16t squared plus, they said the velocity was 116, and then they said the initial height was 101. Now I'm going to set it equal to 0, do the quadratic formula, and solve. So let's use our formula. This whole thing is over 2 times negative 16. I'll finish over here. You get x equals negative 16 plus or minus. That inside becomes 19,920. This is where I recommend grabbing your calculator. So you're going to get x equals negative 16 plus the square root of 19,920 over negative 32. And you're going to get x equals negative 16 minus the square root of 19,920 all over negative 32. So take a moment, plug those into your calculator. As I was doing my math, I noticed I made a mistake right here. This should be 116. Guys, it wouldn't be the last video if Miss Rapp wasn't making a mistake, right? Gotta love it. Gotta go slow with your math. I told you guys, you gotta be really careful. So when you plug it in for the first one, when you're adding, you're going to get 8.0355. They said round to the nearest tenth. So if I round to the nearest tenth, that's just 8. And for the other one, you get, whoops, I had these switched. This one is going to be 8. And this one is going to be negative 0.7855. But if you think about time, it takes 8 seconds because that's how long after the rocket is launched. Guys, great job this semester. We are all so proud of you. Please do the video check-in. You have crushed it. Good luck with the rest of your classes, and we will see you back whenever we do, whenever second semester will start. Have a great rest of your day. Do the video check-in. Goodbye.